Hey folks, how you going? Welcome to a nice sunny 26-degree Australian day in our summer here. I hope you all had a fantastic new year and holiday season. Probably said that already. I think this might be my second video of the year, but I don't know. Is it my first time? It's a blur, really. Anyway, we've got a new product. Luckfox, the lovely people there, were lovely enough to send us their Pico Zero. Now, this has been out for a little while, but they make so many products and they keep sending them to me to test, and I just can't keep up. Otherwise, this would be the Luckfox channel, but I'm trying to keep it all inclusive, of course. So we've got the Pico Zero, and they actually sent us a few. So I'm going to give 3 of these away. This one's still boxed up, that one's still boxed up, that one's still boxed up. These will be given away to the top 3 comments in 2 weeks that have the most thumbs up, suggesting a unique and interesting way to use this product, because there's a lot of things that this can do that I'm going to show you in a moment. But I want to make sure that you got the chance to win one. I will, what is it? It's the 14th today. This video will go out on the 16th. So on the 30th, I will pick a winner. It's whoever's got the most upvotes on the comments. So more details on that later. You get the idea. Thank you, Luckfox. This is the Pico Zero. Let's get into it. This video was kindly sponsored by PCBWay, but more on them in a little bit. Now, looking at the product here, we've got a pretty compact design. So let's see if we can get some focus going on. There we go. It's based around the RK1106G3 that you can see in the middle there. So all the Luckfox Pico series use either 1103 or 1106, the 1106 being a little bit bigger. It's got a 1 TOPS NPU built in for AI use, and it's got 256 meg of DDR3L. We've also got Bluetooth 5.2 and Wi-Fi 6, as you can see here. And we've got 2 different antennas. So we have the onboard ceramic antenna, but we also have the option of an external antenna. And this is just configured through a GPIO that I'll show you. It doesn't come with the external antenna, so you'll need to provide one if you want to use that, but I do have them in stock. Now, I don't actually stock these yet. You can buy them directly from Luckfox, but I will consider it. Moving around the board, we have a lot of things packed in. So we've got an RTC battery connector here, which is absolutely fantastic, especially considering that, you know, these might be running headless with no internet connection, but you still want to maintain accurate timestamps. A speaker connection, along with this microphone over here, this little SMD microphone, as you can see, which is kind of moving this out of their normal Pico range. So Pico's normally just cameras, and you got the Lyra, which is displays, and then the Nova, which is audio. And this is kind of doing it all, as you can see. Typical boot button, reset button, user LED, USB and power port. So this can be USB on the go. It's 2.0, which is what this SoC supports. We've got a MIPI CSI quad lane camera interface here. And so that means you can have a 4K camera attached to this. You've got your 40-pin GPIOs, and this is pretty much the same Pi 2 header that we see everywhere. Some nice mounting holes. And if we flip it over, we've got an 8 gig eMMC on the back, which is absolutely awesome. But we've got the optional micro SD card as well. So what we're going to do is, this is a fresh one out the box. We're going to plug it in and see if it boots up. To do that, we're going to do it over UART, which is using these, the ground and then the TX and RX pins here. And we'll jump in on Linux using PicoCom. I think I've got, what is it? Pico something. I've just started using this. Computer's not working, PicoCom, and I'll show you how to connect to it, what the boot up process is like, how to configure that Wi-Fi, how to join the Wi-Fi, and then we'll look at some of the other options available and ultimately put this on the SBC tier list. Now, to do so, we'll also have to decide what sort of board is this, because I don't think it's an SBC, and you'll see what I'm getting at. All right, let's plug it in and jump over to the computer. So to connect this, I'm just going to use a standard cheap serial to USB adapter. You can get these anywhere. I normally use the CP2104s, and I've got heaps of those in stock, but this was literally sitting on my desk already. So we're not going to use the red voltage line because we don't know what voltage this is going to supply. It could be 3.3 or 5. We'll just power this with USB. What we need is the ground line to make sure that there is a common ground for the TX and RX, and then you want white next for the TX, and then finally green for the RX, and that's from the board's perspective. So if you have a look a bit closely there, you can see how that's connected. We're skipping the 2 power lines, black to black, and then we've got white and green. This I'm then going to plug into the computer over here. I've got a USB port that you cannot see, and that will come up on Linux because I have nothing else connected as TTY USB 0. So jumping over there, here you can see I've got PicoCom, and I've configured this as what's called 8N1. So 115200 is the default board, 8 data bits, no parity, 1 stop bit, and no flow control because we don't have the CTS DTS lines connected. Then we just specify dev TTY USB 0. Now, if you're not sure what it is, when you connect it, you can see what it comes up with in dmessage. So if we tell dmessage to watch and we unplug it and plug it back in, there you can see there is a TTY USB 0. Now, one of the things I like about PicoCom is that we can just connect to it and sit there watching it. Back over here, this isn't actually plugged in yet. So when I plug it in, we're going to see things start to happen on the screen, which is very rapidly going to be the initial binary blob that calls U-boot, that then locates the storage device, the kernel, and boots the kernel. It does that using its special U-boot inner RD, which is built for the image. That's a complex process to talk about for another time, but you can slow down this and watch it if you really want to see some cool stuff. So here we go. As I said, it's quick. The kernel's already booting. That was 800 milliseconds from what I saw. And we are getting into Linux. Come on, come on, come on. Done. Booted. So what you can see here straight away is it's got an IP address allocated. If we have a look at IP-A, USB 0, which is this USB port down here, has 172.32.0.93. So you can connect to that using RNDIS if you wanted to. There's also that WLAN interface, which I can actually point to with the camera over here, that WLAN interface about there, and that's not configured yet either. So let's have a look at the documentation and do that first. If we go to their product introduction, we can see on their Wi-Fi side, by default, it uses the external antenna. So we pretty much just want to copy and paste these lines. If we go paste that, and then, in fact, we don't even have to CD to that directory. We can just go echo out sys class GPIO, and that is the GPIO 1, 2, 3 direction. And then we will want to echo 1 to value. All right, so now that should be using the external antenna, which is this little ceramic doohickey here. Now, I don't believe that these external antennas are as good, these internal SMD antennas are as good as an external antenna. They are definitely awesome for what they are though. So for testing, for basic embedded use, no issue with it whatsoever. I use them most of the time. What we'll do now is modify etc WPA supplicant. This is important because this is how it connects to the Wi-Fi if you want to connect to the Wi-Fi. So I'm going to connect to my Pi-Fi, and of course my extremely secure, never shared before password is Pi-Fi1234. So we save that, kill all -9 WPA supplicant, and if I can remember this off the top of my head, we're going to go WPA supplicant -B -I. No, it's just WLAN 0, I think. WLAN 0 C etc WPA supplicant. Let's see if I got this right. No, I missed something. All right, let's actually check the documentation. Capital B. Capital B is all I was missing. Ah, so close. There we go. Come on. Did I get my password wrong? Initialize supplicant. I probably need to DH, oh no, no, DH client, UDHCPC, ah. All right, there we go. So what we've done here is we've modified WPA supplicant with our details. We've then killed all running copies of WPA supplicant, so it's not sitting there trying to connect to some dud details that were already there. We've then specified to start WPA supplicant in background mode with that interface using our config. Then lastly, we're running UDHCPC, so micro DHCP client on interface WLAN 0. That finally gives us an IP address, and we can probably just go ping google.com, and off she goes. That's all we need to get internet working on this. Now, there are, of course, some other things that you might want to do. One of those is connect directly to the computer. So you might not want to have a UART connection, or you might not have a UART connection to use. That's perfectly fine. You can connect it directly to the computer. So I'm going to grab this tiny USB cable that I've got here. just yoink it like that, which you shouldn't do if you're worried about saving your data on there. And over here, I'm going to plug it in directly to the computer. So first, I'm just going to go dmessage -W, so we're tailing it again. And when I plug this in, it's going to start booting up. The little light's blinking on it, and we should see, there we go, USB 0, an RNDIS device has appeared. So we could, in theory, go down to my connections, and not that one, edit connections, and add a new USB 0 connection. That involves a little bit of messing around, and I can't necessarily be asked with that. There is an even better, cooler way though. If you've got the Android device bridge or the Android tools installed on Windows, Mac or Linux, you get this great little ADB command, and you can just go ADB shell. It's going to start the daemon, it's going to run in the background and immediately connect to the ADB device, which is that Luckfox Pico, as you can see. It has automatically reconnected to our Wi-Fi too, because we save that config. So we've got we've got the USB to serial adapter if you want to connect with serial, which is great for debugging, especially if it's not booting. You can see why, or you can interrupt the boot process and fix it if you've mangled something. We've got RNDIS, which still works on Windows. That's probably one of the easiest ways on Windows. You plug it in, comes up with an adapter. You just might need to specify the driver, which is in that documentation, and then you can connect to it as a network device. And lastly, you've got ADB, which I personally find easiest, especially if you've got multiple devices. You can, wrong one, you can see over here, if I just go ADB devices, you can see we've got that device plugged in there. And if you've got multiple devices, you can connect to them individually. Now, as far as that documentation for connecting on Windows goes, that is actually in here under login. So they cover these 3 different ways to connect. And the RNDIS version is pretty straightforward. It should just come up as an RNDIS device and you set a static IP. However, if that doesn't happen, it doesn't show it here, but you can pretty much just go into your Windows Device Manager, find the unknown device, and set the driver as the Windows RNDIS device driver. Google it, it is really straightforward. So that's basically the ins and outs of how to use this tiny, awesome little device. So let's move on then to what this actually is. And I'm going to put this in the category of an embedded system board, or an ESB. If you haven't heard of that yet, it's probably worth checking out my board taxonomies GitHub, where I've started really breaking this down. If we go over here and have a look, you can see there is a lot of work being done on this, and I really would appreciate any input. I'm working on, I let Claude refine it for me a bit, so this branch actually has a bit more information in it and is a bit more defined. But what we're saying is that an SBC is essentially a full mini computer. It's got an MMU, so it can run full Linux. It's got HDMI out, USB. It's just like a tiny computer, and they're typically that credit card form factor. So there's a few examples there. Those can also come in the compute module or SOM formats, where you might have a carrier and a board. No, they're not always an SBC, but they can be. And I've got some examples there as well. However, you've got an eSBC. The difference here is a lack of GPU capability. So as you can see, the Pico Zero has no, there we go, has no HDMI interface, it has no video out, has no MIPI DSI interface either. It is all input or text comms. So there's no GPU, there's no general computing. It still runs a full Linux. These will run an Ubuntu build, I believe. It's got ISP, it's got SSH, it's got, IO. It is in what is almost that gumstick form factor though. This technically is what's now being called the Zero form factor, which I touch on in these board taxonomies as well. But you'll see some of the other Luckfox products are in that gumstick form factor. And then of course I go into a little bit more in here. So I did say embedded system board before, an ESB, I meant eSBC. An embedded system board goes a little bit further, where there's no MMU. It's not an SoC, it's an MCU. So no MMU, and if it's going to run Linux, it's going to be a really cut down version. Otherwise, they're meant for more Arduino, MicroPython, RTOS, that sort of thing. So this is how I define what these boards are. And I'm going to have to say, this is an eSBC, and I don't mind that. I quite like eSBCs, and they're really, really good for, I guess, edge computing, if you're going to have sensors out in the middle of nowhere, especially considering you've got all your GPIOs, so you can have soil, moisture, humidity, temperature, everything like that. You've got your camera, so if this is in a garden, you can be monitoring plants. You've got easy USB input, so you can get a USB solar supply from DF Robot or somewhere like that. You've then got a speaker. You might want to play nice sounds. You might want to attract birds. You might believe that sound helps plants. There's a lot of things that people suppose helps plants. And then you've got the Wi-Fi for the connectivity. You don't even need to supply an antenna. You don't need to have one mounted sticking up somewhere because you do have that onboard antenna. Not to mention a microphone. So you could maybe set something up to trigger capture on certain noises, or you can have a live feed to your house where you're just watching and listening to the bees buzzing around your plants. I do a lot of gardening, so that's where I would go with this thing, but I'd like to know where you would go with this thing. The reason that's so important is because I will be giving a few of these away. We've got 3 more. Leave the comments below of what you would do with it. How would you make use of all of the capabilities of this device? And if you don't want one, go and have a look at what other people have supposed and upvote the one that you like the most. The way that this works though, as you know, is because of the wonderful, wonderful support of PCBWay. Now, normally I do an ad read a little earlier. I'm going to show you one more thing about the Pico Zero after this, but I did want to quickly let you know that they're still running their contest and that they are still supporting this channel. So there's a link below. If you click that and create an account, it hugely helps me. Costs nothing, and you even get $5 off your first order. So you can do a prototype order and only pay for shipping if you want to start trying to learn how to make PCBs. I did it, you can too. But you can also enter these design contests that they do. You don't have to be good at PCBs. You can also do mechanical stuff if you like CAD, or you can design something using some of these SBCs that I've been showing you. You can win cash, you can win Raspberry Pis, you can win all sorts of cool stuff. So go check them out, and thank you to PCBWay for continuing to sponsor this channel. The last thing that I wanted to show you, there it is a mistake I actually made before. If I plug this back in now, I'm going to show you how to set up the Wi-Fi properly, because you might not have noticed, but I did make a tiny mistake. So jumping over here, ADB shell, IPA, the wireless isn't actually joined. I was probably looking at that one before, and when I thought about it, I thought, why hasn't it joined? So if you go PSAX, you can see the RK Wi-Fi server start is calling it referring to a different WPA supplicant. So let's go copy etc WPA supplicant to data WPA supplicant and just overwrite theirs because we want ours. Now we'll chuck in the old reboot or init 6, give this thing a few seconds to reboot, and it really does not take long. It's usually less than 10 seconds from memory, and then you're back in. And when we're back in, hopefully, there we go, it's joined the Wi-Fi. So PSAX, all right, cat data WPA supplicant. So it's got all of our details there. And we might most likely just need to do UDHCP IWLAN 0. Interestingly, I wonder if this defaults back to using, yeah, let's quickly try this. It might be trying to use the external antenna again. So that might be something that requires a little bit of input or finagling. There's probably things that can be done in the WPA supplicant config after it comes up to do this. But let's try. Yeah. All right. As soon as we switched to the other antenna, it came straight back up. So I apologize for getting that bit wrong before. Simple human error. It does happen sometimes. But this is the Luckfox Pico Zero, another great product from the team at Luckfox, who continue to spit out a ridiculously large amount of great products that they send us to try out on this channel. So thank you to PCBWay, as I said. Thank you to Luckfox for sending this. And now before we put this on the SBC tier list, I do want to thank my patrons as well. They're continuing to join and grow in numbers, and I would love if you would join too. If you've got anything to share, whether it's a few bucks or just some input on my posts, because some of them aren't public, that would be great. If you do join, which is as little as $4 Australian or $3 US, you get access to the videos before they go out with no adverts. You get to join our chats. You get to talk to other people with similar interests, even food and cooking. You get to ask questions, and of course, you get your name in the credits. Now, when you see the membership options, you get an idea of the sort of perks that everything gets. if you pay a fair bit, I'll even let you choose what I review. You might even have too much money, and I'll do whatever I can for you. So thank you to the patrons. Now, looking at this thing, we need to give it a rating. The SBC tier list I'll show you after this, but let's think about price and availability. 20 bucks from China, and I might stock it, and they most likely have it in one or two other places too. I know you can get it from Waveshare, but that ships from the same. So I'm gonna give it, price is fair, availability is mostly China at the moment, 4 out of 5. Features and specs. So it's a good standard Zero form factor. The SoC is as capable as it can get for this sort of purpose. It's got 2 different storage modules. It comes with an 8 gig eMMC by default, which is pretty awesome. 1 TOPS NPU, RTC battery connector, which I didn't expect. Quad lane CSI, which I didn't expect. It's then also got the microphone and a speaker connection, which goes above and beyond for this range of devices. So 5 out of 5 for features and specs. Documentation and support, so easy to navigate, easy to read, includes Mac, Windows, and Linux instructions, and they do have a GitHub where you can raise issues, but the forums are the way to go. So I'm going to give them a 5 out of 5 for the documentation and support too. Now, software and images, the variations are limited. It's pretty much all Buildroot at the moment because they're still negotiating with Ubuntu on how they can be licensed or be able to use the Ubuntu images. There are some unofficial Ubuntu images floating around though. So I'm going to give them a 4 out of 5 for that. It is a fairly recent kernel, I believe. It's 5.15 from memory, and that's limited to the Rockchip SDK, but I know that is also looking at being brought up to 6.12 in the very near future, which will be awesome. So 4 out of 5 for software and images. Performance and reliability, well, it's stock standard. It boots quickly. There was no issues whatsoever trying to use it. The Wi-Fi joined without a problem. All the functionality is built in. I'd say as far as performance and reliability, there's nothing that held it back. Like, there's no reason to give it a 5, but there's no reason to give it less than a 5. And then lastly, accessories. So we've got power over the GPIOs or through the USB port. No PoE for this form factor because it has no Ethernet interface. That's fair. Quad lane camera support for 4K cameras and global shuttle cameras, which is awesome. 2 different storage options. You could also technically use the USB on the go port as a storage option. Sorry, I drifted out of focus there. No display support because that's not what these SoCs are for. The accessories should be pretty vast because it's a standard Pi 2 hat. They've got 2 official cameras supported as well, and no cases, but they should be easy to make because, again, common Zero form factor. So I'm going to give it 5 out of 5 for accessories and compatibility. And I think what's that make it? We've got price and availability, that's a 4. Features and specs was a 5. Documentation was a 5. Software and images was a 4. Performance and reliability was a 5. Accessories and compatibility. That puts it in an S tier. So we now have another Luckfox S tier product. If you disagree, let me know. If I did the math wrong, let me know. I'll always correct myself. But it is a solid product as far as I'm concerned that performed reliably. The only hurdles we had was either me doing things wrong or not having a camera to test it with. And I don't doubt that camera functionality works. So if you haven't seen the SBC tier list before, let's have a very, very quick look at that. It is right here. So every SBC, eSBC, ESB, or dev board I test out goes out on here. And as you see, there's some Waveshare devices. What do we got here? Radshare, Luckfox, ARMSOM. So there's a bit of domination between Luckfox and ARMSOM there, and Waveshare is kind of Luckfox. So they're doing really well. But you can see occasionally they will come out, like the Luckfox Lyra, it lost a few points there. They're working on improving that, same as the Omni or the Core 3576. They always watch these videos. I always give them the feedback about their products, and they're continuing to improve because they're a great team that make great products. So lastly, thanks again for coming along. Thanks to my patrons for supporting me. Thanks to you guys for watching this video. Don't forget to like and thumbs up. Oh, I just got the worst knee ache or leg cramp. Jesus, what was that? And leave a comment below of what you would use this for. Maybe you will win one, but you're still contributing to the community, or just feedback. It's always greatly appreciated. I hope you're doing well. I hope my audio worked in this video. I'll catch you guys in about 2 weeks. Take it easy. Oh, thanks PCBWay too. I can't forget them. I keep forgetting them. PCBWay, check them out. Link below. See yous.